Hey there, this is KHADER Electronics Made Easy. So recently there were too many power cuts in my apartment, due to which whenever during the night the power goes off, I have to keep searching for my mobile or the torch to be able to see in the dark. So just to avoid the situation, I thought I'll make something which can automatically switch over and turn on the light whenever power goes off and it's dark. Let's see how. So we are going to use this circuitry for our switchover system, and for the battery I'm using here the 6 volt 5 amp hour lead acid battery. So I'm using this one because this can store quite a lot of power, and in future if I want to add a mobile charging I can also do that with this. So coming to the circuit, as there is a battery we would need a charging circuit. I'm using a very simple charging circuit here. Here if you see, there's the transformer which drops 220 volts AC to 12 volts AC on this side, and this transformer output of 12 volts is connected to a bridge rectifier to convert AC to 12 volt DC. Once this is connected, we connect a capacitor here, maybe 220 microfarad. This capacitor is to convert AC to DC signal. This DC signal is connected to a buck converter which drops down this signal to further low, and this is adjustable. So these buck converters come with an adjustable potentiometer which can be turned to low down the voltage further. And this buck converter output is connected to a diode which is a 1N4007 diode, and this diode, through this diode, is connected to a relay. So this is a relay where if you see closely, we'll have 5 pins with one as a common pin. This common pin, the center pin, is connected to the battery here, and out of these 2 pins, these 2 pins are one connected to the power supply output here, and the other is connected to our LED lighting system. So which one should be connected to what is? The one connecting to the power supply should be the one which is normally open. So if you see the relay here, the center pin is connected one to this one all the time, and the other is not connected all the time, which is open all the time. So the open one should be connected to the power supply, and the other one should be connected to the circuit. Apart from this, the 2 pins on the either side of the center pin, this one and this one, are for the coil, which are directly connected to the output of the buck converter. So whenever the power supply is on, the relay is on, it will be connected to the power supply, and the power will flow to the battery and battery charge. And when the power goes off, this relay will switch and connect directly to this circuit, switching it on. So coming to this circuit, this is a simple Darlington pair of transistors, and these 2 transistors with an LDR, which is a light dependent resistor at the base of this transistor. So whenever there is light falling on this LDR, it will switch off this transistor, and this transistor will stop the current going to this transistor, and the LEDs will be off. Whenever the light stops from falling on this LDR, the current will flow from positive rail through the base of this transistor, and this transistor will switch on, send current to this transistor, and this will switch on, and finally the LEDs will be turned on whenever there is no light. So this is a pretty simple circuit which can be used to switch on the LEDs whenever the light goes off. Now let's try making this circuit and see if it works. So I'm done with the circuit here. As you can see, I've connected a wire with plug here to the transformer, and from the transformer I have connected a bridge rectifier with a capacitor as I showed in the circuit. So this bridge rectifier is a rectifier IC. You can also use 4 diodes to achieve the same thing, and here I have connected a 1000 microfarad capacitor. The higher the capacitance, the better filtering it will do. So the output of this circuit is connected to this buck converter or step down converter, which has a potentiometer to vary the voltage. So what will happen is there will be a 12 volt AC output of this transformer, which will be converted to 12 volts DC using this circuit, and this DC is connected to this buck converter, output of which is a variable step down voltage. So here we are using a 6-volt battery, so we'll be setting the output voltage of this one somewhere around 7 to 7.2 volts, so that the battery can charge to its maximum voltage. I think that's around 6.3 volts or something, so you can maximum charge to 6.3 volts. So output of this buck converter through a small diode is connected to this relay, the same circuit diagram which I showed previously, and the relay is connected to this switching circuit with an LDR, and the output is an LED. Here I have connected a single LED instead of 2 LEDs as I showed in the diagram. I connected a small resistor to limit the current with a 1 watt LED, and this is the LDR which will be seeking the light, and based on that it will operate the LED. So first we will connect the transformer, switch it on. So as you can see, the output here shows it's switched on. Now we'll set the voltage to approximately 7 volts. Okay, so almost approximately 7 volts approximately, so I don't think I need to vary again. And now we'll connect the battery here. So I've already connected these clips to connect to the battery, and positive to positive, negative to negative. And now if we cover this LDR, the light shouldn't switch on. Perfect. Now to mimic the power cut, I'll be switching off the input of this transformer. So I'll switch off the input. Now I'll cover the LDR. As you can see, whenever I cover the LDR, the LED starts glowing. So that means it's working. So one thing is, we cannot put the LDR where the LED already is. So what will happen is, when we place the LDR directly in line with the LED, whenever the LED switches on, it will feed it back through the LDR to the circuit, and the LED will switch off. So it will oscillate, or it will switch on and switch off automatically. So make sure you place the LDR somewhere where the light from this LED doesn't fall on the LDR. So this circuit I'm going to fix in my near my bed as a bed light, because mostly in the night when I'm on the bed, or when I'm reading something in my bedroom, suddenly the light goes off and it's completely dark and difficult for me to find my phone or the torchlight. So placing this circuit would be helpful for me during the night, because I'll be able to grab a hold of a torchlight or something in this light, and it can also be used as a bed light. If the power goes off, this can be powering the light for the almost. I think this can easily run for 2 days on this battery. This is a bulk battery, so it can easily use it. So that's all for today's video. If you like this video, please consider subscribing to my channel and press on the bell icon so that you can get regular updates whenever I post videos. I'll see you in my next video. Till then, thank you.